I hope my screen is visible, and you may be getting quizzes randomly. Okay, make sure that you all attend the quiz, and the link has already been posted. So I don't think so. Why people are getting it late to the class? Okay, so anytime I'll be like posting you some questions. Make sure that you attend to the quiz as well. So in the previous class, we were seeing about all the data pre-processing technique. So today, like we will be learning about the data integration. Okay, so data integration, it is the task of merging together the data from multiple sources. Okay, so when the data is integrated from the multiple sources, we have to ensure that the integration should be done so carefully in such a way that that helps to avoid the redundancy and inconsistency, and as well as it helps to improve the accuracy and the speed of the machine learning process. So the reason, like we have to make sure that the data is consistent. And when we do the integration, like we have an entity identification problem. Okay, so how can the data analyst or the computer can be sure of when someone of you would have stored in the register number, sorry, the customer ID as one database and customer number, which also refer to the same attribute but in a different name. Okay, so we have to make sure that during the integration, so some of the resources also match with the other. Okay, so and this smart schema integration and this object matching can be tricky. Okay, so we have to make sure that the metadata for each attribute. Okay, so the meaning. Okay, what type of data it can take. What are the permitted range of values, and if there are null values, how the null values can be handled. Okay, so such metadata can be used, and that helps to avoid the errors in such schema integration. If we don't do a proper metadata, then we see that the schema integration will be very challenging. And redundancy and correlation analysis, like the redundant data usually occurs for the following reason. The first one is object identification. Okay, so the same attribute, okay, but it will be having the different name in the different data bases. Okay, so that is one problem. And the other issue is the derivable data. So one attribute may be derived from the another. Okay, so we have to make sure that such type of attribute should not be stored again and again. So one data set you'll be referring as customer age, and in the other data set you'll be referring to the same value, but you'll be making use of the date of birth. Okay, and all these things we have to make sure that. See, even now I say that if any one of you finds it difficult, ask them to connect immediately, but don't disturb during the class. Still, we could observe only 63 of you are connected. If anybody is said like admit, please let me know. Okay, so this redundancy becomes a challenge. Okay, and some of the redundancies can be identified by using the correlation analysis. And say, for example, when you have a collection of attributes, and if you want to understand how strongly, how closely the attributes are related to each other. Okay, in that case, for the nominal type of data, we need to make use of the chi-square test, and if it is for the numerical attributes, we need to make use of the correlation coefficient and covariance. So that is the test that will be like making use of it. And the correlation test for the nominal type of the data can be done with the help of this formula, that is Pearson statistics, where we see that summation I is equal to 1 to C, summation J is equal to 1 to R. Okay, so to the collection of the rows and the columns in the input data set, it is the square of the difference between the observed and the expected, the whole square divided by the expected. Okay, so this is the formula that we'll be making use of it for the correlation analysis. So here you'll be like having the chances of having the problem in this like correlation analysis. Say for
Ma'am,
example, yes, Pa?
some of them are
Yes.
waiting to join the meet, ma'am.
So is there anybody yet to join? Okay, so please tell them to like connect. You can't just be waiting for all the students. Make sure that all of them connect on time. Okay.
Okay, ma'am.
Okay. So, say for example, you have a group of 1,500 people, okay, and we see that there was a, polling, okay, and to find out what is the preferred type of reading, whether it is fiction or non-fiction for both the female and the male. So, and this is represented in the form of a contingency table, and we see that 250 it is an observed, okay, but the expected is given within the parenthesis, okay, and 200 it is the observed, okay, and 360 it is the expected, okay, and according to the formula, it is the square of the difference between the observed and the expected, the whole square. So the
Some of us are waiting also.
that's what, like I gave
Let them.
repeated instruction, ma'am. How much time should I need to give the instruction? I gave the link, and the link has been posted in the WhatsApp group, and it had been shared in the meet. But you don't want to like come on time, right? Okay, so on doing this calculation, we get the answer as 507.93. Okay, so and from this, we also have to calculate the degrees of freedom from this contingency table, that is C minus 1 into R minus 1. So the number of column minus 1 multiplied by the number of rows minus 1. So we see that in this matrix we have two rows and two columns. So on doing that calculation, we are able to get the degrees of freedom as 1. So for 1 degrees of freedom, okay, and there are certain levels of significance. So let us assume that the significance level for this problem is 0.001. So according to this statistic table, okay, so if the significance level is 0.001, and if the degrees of freedom is 1, and the calculated p value is 10.83. Okay, and the we need to compare the calculated value with the calculated chi-square value. Okay, we need to compare the chi-square value with the value that we get it from the statistics table. Okay, when we compare, we are able to understand our calculated value is greater than the value what we get it from the statistics table. If the calculated value is greater than the one that we get it from the statistics table, then the conclusion is we need to reject the hypothesis. So initially, like we will assume the initial null hypothesis. We'll assume as if the two attributes are dependent on each other. Okay, and after calculations, so since the calculated value is greater than the one that we refer it from the statistics table, then we need to reject the hypothesis. In case if our computed value, if it is less than this value, then we need to accept the hypothesis. In this scenario, we reject the hypothesis and we can conclude that the gender and the reading are independent of each other. Okay, there is no dependency between the two variable. Okay, so this is the correlation analysis that we use it for the chi-square test, and especially for the categorical type of data. Okay, especially for the categorical type of data. And the next is like you have your correlation and correlation, covariance and correlation of the numeric data. So covariance, it is the measure to indicate the extent to which how these variables change together. Okay, so mainly it helps to identify the focus on finding the linear relationship between the two variable. Okay, but correlation, it helps us to measure the strength of relationship as well. Okay, it helps us to measure the strength of relationship between the two variables. So the covariance can vary between minus infinity to plus infinity, and correlation, it takes a value between minus 1 to plus 1. Okay, so and from this covariance we can understand that how the variables vary together. Okay, so if it is positive covariance means the variables are positively correlated. Okay, when there is an increase in one variable, there is an increase in another variable. So the negative covariance means they are inversely related. When there is an increase in one variable, there is a decrease in the other variable. So as the age increases, the price of the car reduces. As you increase the number of hours that you put in for your preparation, and the marks will increases, and you also get a better placement, which is an example for the positive covariance. So this is the formula to calculate the covariance relationship between the two variable x and y. Covariance of x comma y is equal to summation of x minus x bar into y minus y bar divided by n. So if the formula, whatever you are going to consider, if you are going to consider the population, then the denominator should be n. And if you are going to consider only a sample size, the denominator should be n minus 1. The denominator should be n minus 1. So if the calculated value, if it is minus 1, then the variables are negatively correlated. If it is plus 1, they are positively correlated. If it is 0, then the variables are not correlated. Okay, so there is no relationship. And this is an example how we can calculate the Pearson covariance and the correlation coefficient between the variable x and y. Okay, so the relationship between the temperature and the number of customers. So here also we see that from this you can calculate what is your x bar, what is your y bar, and then x minus x bar and y minus y bar. And the last column, you can take the multiplication of these two values x minus x bar and y minus y bar. So according to this formula, when we take the calculation summation of x minus x bar into y minus y bar divided by n minus 1. Okay, so in that case, when you do this calculation, we are able to get the answer as 22.46. So the calculated value is positive, thereby the relationship between the temperature and the number of customers is a positive relationship. So as the temperature increases, there is also a linear increase in the number of customers. So and then we have the correlation. So from this correlation, we can understand what is the strength of correlation between the two different variable. Okay, so the strength or the correlation can be calculated by using the formula covariance of x comma y divided by sigma x into sigma y. So on doing this calculation, when you substitute these values into the formula, and we are able to get the answer as 0.8. So where we see that the strength of the relationship, okay, if the value is greater than zero point 0.7 and closer to 1, and that gives an understanding the two variables have a very strong relationship. And the next topic is tuple duplication. Okay, so here this is a technique. Okay, so how we can eliminate the redundancy at the tuple level. Okay, so normally we'll be calculating the redundancy between the attributes, but at the row level. Okay, so how we are able to calculate the duplicacies. Okay, so in that case, when there are redundancy, often it can lead to the inaccurate data entry. Okay, so sometimes updating some of the information also may not be possible. Okay, so we should be able to identify the first row and the fourth row, they are duplicate. Okay, so we should be able to eliminate such errors. And data value conflict detection and resolution is when the data is merged from the multiple sources. Okay, and we see that there could be a conflict where the data is represented differently across the different data sets. So for example, price may be represented in different currencies in different cities. So we should be able to avoid the conflict, and we should be able to detect and avoid such conflict. And data reduction. Okay, the last type of the next type of the data pre-processing is the data reduction. So especially in the complex data analysis, when we are extracting the useful information, if your data set is huge, and it might take a longer time to get the output to do some decision making. So the data reduction technique can be applied in order to have a reduced representation of the data set, so that you'll be able to yet maintain the integrity of your original data. So we see that when you look at the overview of the data reduction, so under the data reduction, we have the dimensionality reduction, numerosity reduction, and the last one is the data compression. Okay, so the dimensionality, when we see that when a data is integrated from multiple sources, the data is extremely complex because there increase in the number of features. So the curse of dimensionality describes the phenomenon where the feature space increases, where there is an increase in the number of dimension. So it is obviously we need to think like how we can even represent the closest neighbors being too far away in a high dimensional space. Thereby we are able to get a better estimate. So in this dimensionality, the first one is the dimensionality reduction. Dimensionality reduction, it is the process of reducing the number of attributes that are taken into consideration. Okay, under this we have two important technique. One is feature selection. So feature selection, it is the process of selecting the subset of important features that is needed for developing the application. Okay, and in order to reduce the complexity of the model and helpful to improve the computational efficiency. And feature extraction, the second one is feature extraction. It is a process of transforming the original features into the new set of features, and thereby we are able to preserve the information in the original data set. So for that, under this dimensionality reduction, we have the different type of transformation. We have wavelet transform, we have principal component analysis. That is mainly it is used to transform the original data into a smaller space. And then we have an attribute subset selection, and this is a method that is mainly it focuses on dimensionality reduction. Okay, so maybe if there are any redundant attributes, you can remove it, and if there are weak, if there are any irrelevant attributes, that can also be eliminated. And the next method is attribute construction. Okay, so attribute construction, it is a method where a smaller set of more useful attributes can be derived from the original set. Okay, so you need not store the information for each and every feature. Okay, but obviously we'll be able to derive it from the original data set. And these transformation, we see that it is a dimensionality, and this transformation, it is just applied to get a compressed representation of original information. Okay, and if you are able to get a reconstruct your original information without any loss of information, then such type of data reduction technique, it is called as what? Lossless. And in case if you are not able to reconstruct back your original data, then that is called as lossy transformation. So we see that we have the methods such as the wavelet transformation. It is a linear signal processing technique. And when you are going to apply this technique into some data vector, it is able to transform the numerically that particular vector into a different numerical vector. Okay, but they will be of similar length. And principal component analysis, and it is a method which can search for the dimensionally orthogonal vectors which is best suit for the representation of the data. Okay, that is mainly that is used better represent the data. So this principal component analysis, and it is a technique that is able to represent the original data into a much smaller space, resulting in a dimensionality reduction. Okay, so unlike the attribute subset selection, which reduces the attribute by retaining the subset of the original attribute. So this is an alternate technique where the initial data can be projected into a smaller set. Okay, the original data you are going to represent it into a smaller set. So mainly this principal component analysis, it helps to maximize the variance in the data set. Okay, so it helps to find the line of variance in the data set, which is called as the principal components. With the first principal component will have a maximum variance, and followed by the second principal component having the second maximum variance. And these are all the some of the steps of the principal component analysis. The first step is like we need to standardize the data. We need to do a scaling, thereby the data falls it within the particular range. And you have to calculate the covariance matrix and how we are able to find the correlation between the different variables in the data set, and then mathematically you substitute the eigenvector and eigenvalue based upon the covariance matrix, and then find the principal component analysis. Okay, so the computation of the principal component analysis will be done based upon the calculation of eigenvalue and the eigenvector. So the one with the highest eigenvalue is the most significant form, and it is the first principle. component. Okay, so we should be able to rearrange the original data with the first principal component that represent the significant information. And this PCA can be applied for both the ordered and the unordered type of attributes, and as well as it is capable of handling the dense and as well as the sparse data. So this multi-dimensional data of two or more dimensions can be handled by reducing the problem to two dimensions. So, in comparison with the wavelet transform, PCA tends to be better at handling the sparse data, and wavelet transform is more suitable for the high dimensional data. So, wavelet is more suitable for the higher dimensionality. So, and this is an example where initially we have 1599 rows with 12 columns, and after applying the principal component, and we are able to find what are all the top features, and we are able to find the top three features. And then we have the attribute subset selection, and this is a technique that helps to reduce the data set size and by mainly by removing the irrelevant attributes. Okay, so if there is something not related to your problem, okay, and something which is not suitable for your problem. So the goal of this subset selection is to find a minimum set of attributes, so thereby you are able to get a probability distribution very closer to the original distribution. So for n number of attributes, we see that there are possibly 2 to the power n possible subsets. Okay, so and it is always a good practice for us to explore and find a reduced search space. Okay, so for the attribute selection. Okay, and this is all done based upon the information gain. And for this, we have the four different techniques for the attribute subset selection. The first one is the stepwise forward selection. So the step, it will initially begin with an empty set of attributes. And among the initial set of attributes, the best of the original attribute is determined and it is added. Okay, so we see that in the first iteration, A1 is found to be best, and in the next iteration, we see that A4 is found to be best. So, and at every iteration, okay, so we just keep on adding the best of the attributes to your set. So this is the reduced set of representation. And backward elimination, we will begin with all set of attributes in the first iteration, and at the every iteration we'll be keep on eliminating the worst attribute remaining in the set. And the last one is the combination of the forward selection and the backward elimination. So where we see that, and this is the method that at every procedure, it will be able to select the best attribute, and as well as it will be able to eliminate the worst from the remaining attributes. And the last is the decision tree algorithm, where we have the algorithms such as ID3 algorithm, CART, and these are all mainly intended for the classification purpose. So the decision tree, it starts with the construction of the flow chart like structure, where the nodes, it represents the test on a branch, okay, and each branch, it corresponds to the outcome of the test, and the leaf node, it represents the prediction or the classification. So at every node, we see that the algorithm chooses the best attribute to partition the individual class. So the other feature selection methods, we can either remove the unused column, okay, by having a domain expert and removing the columns with outliers. So, and wherever we see that when the mean value is greater than median, okay, and there is a chance for outlier, and there could be features with the missing value by using the method such as is null dot sum of. So always better to have if it is less than more than certain percentage, it is not good for us to have such features, and we can eliminate the features with very low variance and remove the uncorrelated features and remove too highly correlated features as well. So for this, we have the methods such as the univariate statistics. So and these are all the statistic by applying the statistical technique, and we'll be able to find the significant relationship between the feature and the target. Okay, example, applying the techniques such as the Z test and P test, and we'll be able to select the k best number of features. So the k best number of features from the given number of input features. And model based feature selection. Okay, so model based feature selection is based upon the regression or the classification model. We'll be also able to do select important feature. And iterative feature selection. So an iterative feature selection, it makes use of series of models are built. Okay, where we see that it uses the techniques such as recursive feature elimination. Okay, where it starts with all the features, builds the model, and every iteration it will discard the least important feature according to the model. And every time when we build, okay, when we see perform this data selection, we have to ensure we should be able to reduce overfitting, improve the accuracy, and we have to make sure we are able to reduce the training time. So attribute construction, how we are able to construct the new features from the already existing features. Okay, so by combining all these features, the attribute construction can discover the missing information about the relationship between the attributes and the target. And the last one is the numerosity reduction. Under this, you have the methods such as the parametric methods, where you build the with using the graphical representation, we'll be able to perform the numerosity reduction. And we have a non-parametric method where you can apply the techniques such as the histogram, clustering, sampling. Okay, so the regression, okay, we have a simple linear regression where you'll be finding a best fit line to find the better fit all the data points, which is represented by the linear line, that is y is equal to mx plus b. Okay, you'll be finding a slope and an intercept. You know what is multiple linear regression and also the logistic linear regression, and all these that comes under the parametric approach. Non-parametric model is where how we are able to represent the data set. Say for example, the histogram, okay, and how you are able to partition the data set into the subsets, where x-axis it represents the different bin and y-axis it represents the frequency of occurrence. Okay, so maybe the age into the different categories, you put it into the bin and you can count how many number of values are there. So under this also you have an equal bit where how we are going to do the partitioning. Okay, and maybe you put the age 1 to 10 under one category, and then 11 to 20, 21 to 30, and equal frequencies like such that the count in each and every like the bucket is same. Okay, so you keep the frequency as similar. And then you have your clustering. You all know that we need to maximize the distance between the any two objects. Okay, and sampling. Okay, so whenever you do any analysis, there are two different methods. That is simple random sampling without replacement. So without replacement, you draw a certain samples, do the analysis, but you don't replace it. And random sampling with replacement, where you draw a sample and do the analysis and replace the record back again. And you have the clustered sampling and stratified sampling, where the sample is divided into mutually disjoint parts called as strata. And the advantage of such type of reduction is that the cost for obtaining the sample will be as opposed to the data set size. And then you can have your aggregation, like what you have studied in the previous module. Okay, so we can do pre-compute and store the summarized data, like do a data calculation, what is the total sales per year, and then how the cubical representation. You have your base cuboid at the least level of abstraction, where you will have the representation about each and every individual entity of interest, and the apex cuboid is the highest level, where you have a total aggregate information for all the set of attributes. And then we have the compression, we have the lossy compression and the lossless compression. Okay, so lossy is will not be able to reconstruct the original data back, and lossless, it is a type of construction where we'll be able to reconstruct the original data back. So with that, all your data pre-processing technique is completed. You just wait for a while. Now you can just mark your attendance now, okay? And the link will be closed within another 2 minutes of time.